It began quietly, long before anyone realized what it would mean. When astronomers first detected the object in July 2025 through the ATLAS survey in Chile, it seemed like another distant, icy visitor. But within hours, something felt off. Its orbit wasn't elongated like a long-period comet or looping like an asteroid trapped in the sun's gravity. It was hyperbolic. That meant only one thing. This object wasn't staying. It wasn't circling. It was passing through the solar system on a one-way trajectory, never to return. It instantly became the third confirmed interstellar visitor in history after Oumuamua in 2017 and Borisov in 2019. But even compared to those anomalies, this object stood alone. Its speed was staggering, more than 210,000 kilometers per hour, the fastest interstellar object ever recorded, and its path would bring it surprisingly close, about 1.36 astronomical units from the Sun, and later roughly 1.8 AU from Earth, around 267 million kilometers away. Not dangerously close, but close enough for humanity to watch every detail. And the details did not behave as they should. From the first observations, its light signature defied categorization. It was too reflective, too stable, too structured. Real comets shimmer and flicker as dust scatters sunlight. This one reflected light like a body with uniform surfaces. Scientists watched, confused, as its brightness remained steady even under fluctuating solar radiation. Whatever it was not behaving like a natural wanderer. As it moved toward the sun, stranger anomalies appeared. Hubble detected something unprecedented. A bright anti-tail, a jet of material extending toward the sun instead of away from it. Solar radiation always forces comet tails outward, but this one was reversed, like smoke drifting against the wind. Weeks later, the anti-tail flipped direction, snapping into a normal outward tail with a symmetry so sharp, so controlled, that astronomers questioned whether it was a natural reaction or a maneuver. Observatories in Hawaii and Spain confirmed the shift. Meanwhile, the James Webb Space Telescope uncovered something even more disturbing. The coma surrounding the object was composed of 87% carbon dioxide, 9% carbon monoxide, and only 4% water. No comet in our solar system has anything close to that composition. It was bone dry, almost airless, and yet it glowed in the infrared as though heat was coming from within. Then came the CO2 cloud, an enormous shroud, nearly 350,000 kilometers across, larger than Jupiter's diameter. Inside it were traces of hydrogen cyanide and a strikingly high ratio of nickel with almost no iron. Natural objects don't show that metal ratio, but industrial alloys sometimes do. As the object reached perihelion, astronomers braced themselves for it to disintegrate. Countless comets have died this way, shattered by intense solar radiation. Instead, it survived. Not only did it survive, it emerged brighter and more stable. A massive coronal mass ejection struck directly across its path, a blast powerful enough to vaporize fragile ices instantly, but the object barely reacted. Its temperature rose briefly, then stabilized, as if something inside was regulating it. Its shape added another layer of unease. Long and thin with an aspect ratio of 10:1, it mirrored the proportions of Oumuamua. But while Oumuamua tumbled chaotically through space, this object remained steady, its orientation fixed. It reflected light with a strange negative polarization. A property no known comet or asteroid has negative polarization doesn't occur naturally. It requires smooth, structured surfaces. Scientists began calling it the unbreakable visitor. And behind the scenes, conversations grew darker. Harvard astrophysicist Avi Loeb placed it in Category 4 on his extraterrestrial probability scale, a classification assigned to interstellar bodies that show multiple anomalies inconsistent with natural formation. According to his calculations, there was a 40% chance, 40, not 4, that the object was technological. Many dismissed the idea as speculation, but with every new anomaly, skepticism felt more like denial. Right now, as it moves through its most critical phase, physicists like Mio Akutsu are watching for a specific signal. If the object accelerates in a way that exceeds what solar gravity predicts, the conclusion becomes unavoidable. It would mean propulsion. It would mean intention. And it would mean the object is under control. The maneuver they're waiting for is known as the Oberth effect. Spacecraft exploit it by firing engines near a massive body like the Sun, converting gravitational potential into enormous bursts of speed. If this object performs even a hint of such a maneuver, it will gain kinetic energy no natural comet could accumulate enough to slingshot into deep space, or worse, to redirect toward a planet. NASA knows what's at stake. That's why it quietly activated its Planetary Defense Network, a global coalition of more than 227 observatories. Publicly, it was called a training exercise. Privately, the timing was too perfect to be coincidence. Researchers also began hearing rumors. Radio telescopes had detected a faint but consistent signal synchronized with the object's rotation. Was it noise, interference, or was it the faint voice of a machine older than civilization? After perihelion, the impossible happened. The object slowed down. Not from drag or gravity, not from solar wind pressure, but in a way that resembled controlled braking. Data from NASA's Jet Propulsion Laboratory and the European Space Agency measured a decrease of 0.08 meters per second squared over 20 hours. A tiny shift, but smooth, consistent, deliberate. Objects shaped like this don't slow down on their own. They accelerate away from the Sun. They don't resist gravity. They don't stabilize internal temperatures. They don't survive coronal ejections intact. But this one did. Exactly as it crossed the thermal equilibrium zone, where internal heat equals incoming solar energy, its velocity decreased, as if reacting to the environment in real time. This was the moment many scientists had feared. Something inside the object might not just be regulating temperature, it might be adjusting its course, and this was only the beginning. Days after the object began its unexplained deceleration, the strangeness deepened. A research array in Japan, the Mitsuhara Deep Space Radio Observatory, detected a narrowband signal coming from the direction of the object. At first, it was faint, almost ignorable, like a whisper beneath static, but it repeated. 3 pulses, then silence. 3 pulses, then silence again. The interval between each sequence was exactly 247 seconds. That number mattered. It was the same interval detected months earlier when the object was behind the Sun, an anomaly dismissed as interference at the time. But this time, the pulse wasn't alone. The signal was stable, far too stable for anything produced by cosmic noise. It didn't bend with solar wind or warp through background interference. It held its shape like a beacon locked to a metronome. Independent observatories in Chile, Italy, and South Africa confirmed the detection within hours. Whatever this was, it was real. Worse, it carried faint harmonics in the hydrogen band, the universal frequency hypothesized in interstellar communication theory. It was as if someone had chosen the one wavelength they knew any intelligent civilization would monitor. NASA refused to comment publicly, but an internal message leaked from the SETI Institute suggested something far more unnerving. The signal exhibited phase coherence. Random natural emissions do not maintain coherent phase structure. Only engineered signals do, and the moment that truth settled in, the scientific community split in half. Some insisted the entire chain of anomalies, tail reversal, negative polarization, metal-heavy composition, deceleration, infrared emission, could still be explained by exotic natural processes. But the other half saw the growing pattern and understood the weight of what they were witnessing. No comet behaves this way. No asteroid sends periodic radio pulses. No interstellar rock regulates its temperature or slows down at the thermal equilibrium zone. As debate spread, the James Webb Space Telescope was quietly repositioned to track the object from its vantage point at L2. Webb's readings were unlike anything recorded before. The surface wasn't just reflecting light, it was modulating it. Polarization alternated rapidly, microsecond by microsecond, as if layers of material were shifting orientation. It reminded some researchers of adaptive optics, systems that adjust surfaces to correct distortions. The timing of these modulations matched the radio pulses. The object was emitting in light and in radio, synchronized, steady, deliberate. At the same time, telescopes in Chile captured footage of its tail splitting into 2 distinct streams, not parallel, but crossed at a 90-degree angle. Cometary outgassing never produces perfect geometry. Natural jets fan outward chaotically, widening with distance. These two beams held their structure, intersecting with mathematical precision. It was as if the object were using its own gases as an optical broadcast system, sending beams across space like a coded pattern meant to be seen from afar. Questions grew darker. What if the tail wasn't a tail at all? What if it was exhaust? What if the object wasn't shedding material randomly, but intentionally shaping emissions for communication? Then, on August 29th, everything changed. As the object moved beyond Earth's orbital plane, tracking stations noticed a shift in its trajectory. A small shift, subtle but undeniable. 0.11 degrees. That number meant everything. Natural objects drift, they wobble, they scatter. They do not perform crisp angular corrections. But this one did, and it did so while crossing into a perfect alignment. For 27 straight hours, its projected path fell into a line that passed through Mars, Jupiter, Saturn, Uranus, Neptune, and beyond. An alignment so precise that the odds of random occurrence were close to zero. Astronomers stared at the models in disbelief. The object wasn't just moving through the solar system, it was calibrating itself to it. Webb recorded luminescence patterns pulsing from its core, each fluctuation matching the orbital resonances of the planets it aligned with. It wasn't coincidence, it was choreography. If this were natural, it was the most complex natural phenomenon ever recorded. If it wasn't natural, then something was mapping the solar system. Just as tension reached its peak, the object emitted something no one expected. A visible ultraviolet flash, a burst lasting 2.8 seconds, powerful enough to ionize the solar wind in a tight beam. It wasn't scattered, it wasn't chaotic, it was directional, aimed with precision toward deep interstellar space. When scientists traced the vector, another shock hit them. The flash pointed directly toward the region between Vega and Lyra, the same sky zone where the famous WOW signal was detected in 1977, the same coordinates that sparked decades of speculation about an intelligent broadcast. The resemblance was not subtle, it was exact. Silence followed. The radio pulses stopped. The light fluctuation ceased. The tail went still. The object that had been sending signals, performing maneuvers, shifting polarization, modulating emissions, and aligning itself with planetary orbits suddenly went dark. Not destroyed, not drifting out of range, just silent as if it had finished whatever it came here to do. For days, telescopes hunted for a signature. They found none. Even the James Webb Space Telescope, capable of detecting distant galaxies, couldn't find it. It was as if the object had folded itself into invisibility. NASA declared it optically lost. But the statement didn't match the fear in the private briefing rooms where scientists stared at the last recorded data, because just before the ultraviolet flash faded, one more anomaly had been captured, buried in the raw light curve. It wasn't a tail, it wasn't a jet, it was an interference pattern, like a fingerprint left in light itself, a modulation etched into the energy of the flash. When the Harvard-Smithsonian Center for Astrophysics reconstructed the pattern, they found structure, repeating frequency ratios, harmonics matching hydrogen transitions, planetary resonances, and, most disturbingly, a faint echo of Earth's atmospheric frequency. It was a message written not in words, but in geometry. This wasn't the end of the story. This was the moment the object finally spoke. Now, the world waited, unsure of what would come next, and they didn't have to wait long. For weeks after the ultraviolet flash, every telescope on Earth pointed toward the object's last known coordinates, but the sky remained empty. It hadn't fragmented, it hadn't slowed, it simply vanished from every instrument capable of detecting it. Even the James Webb Space Telescope, which could spot a galaxy billions of light years away, saw nothing but cold darkness. NASA officially labeled it optically lost. Unofficially, no one believed it had simply disappeared. Something that moved with such precision did not drift into nothingness. Something that had aligned itself with planetary orbits and emitted ultraviolet signals did not randomly fade away. Deep inside the data archives of Webb, a small team of researchers refused to accept the silence. They dug through the final milliseconds of readings captured just before the flash faded. What they found changed everything. The light wasn't just bright, it was encoded. Hidden inside the ultraviolet burst was an interference pattern, subtle, delicate, but too structured to be noise. When they reconstructed the signal, the pattern revealed repeating frequency ratios, the same ratios found in hydrogen transitions, the same mathematical harmonics seen in orbital resonances, and an echo faintly matching Earth's own atmospheric electromagnetic frequency. The flash hadn't been illumination. It had been information, a message written in light. When the Harvard-Smithsonian team ran the data through waveform analysis, they discovered something even more extraordinary. The structure inside the signal resembled a three-dimensional lattice. Spirals nested within spirals, harmonic layers forming a shape eerily similar to a double helix, not DNA, but the same universal geometry that governs natural growth, entropy, and the distribution of matter. It wasn't text. It wasn't sound. It was a blueprint encoded in vibrations, a cosmic signature not meant to be read with eyes, but experienced through resonance. Avi Loeb, who had warned from the beginning that the object showed technological hints, described the discovery as the closest thing to intentional encoding humanity had ever seen. According to his model, the geometry represented resonant storage, a method of embedding enormous amounts of information into energy patterns instead of symbols. If true, the message wasn't a greeting, it wasn't a warning, it was something older, something more fundamental, a memory stored in the structure of light itself. NASA classified the data immediately, but not before several independent researchers extracted raw copies of the waveform and ran it through quantum simulators built to test theoretical frequency interactions. At first, nothing happened. Then, slowly, a repeating harmonic emerged, rising in intensity with each cycle. It was as if the waveform was interacting with the simulation field, syncing with it, trying to unfold into a higher dimensional structure. For a moment, the resonance looked like it was about to stabilize. Then, without warning, the signal inverted. The simulator shut down automatically, and the system locked itself. But not before the translation module, a neural A I trained to interpret. Mathematical patterns as linguistic structures generated one final line, a line that researchers stared at in stunned silence. It read, "We remember you." The phrase leaked briefly before being wiped from public servers. NASA denied everything. SETI fell silent. The European Space Agency locked its archives under cosmic anomaly protocols, but the truth had already spread among those who understood the implications. This wasn't coincidence. This wasn't nature mimicking intention. This was intention. And then something even stranger happened. 2 months after the object vanished, multiple observatories began detecting faint harmonic pulses within our own solar system. Not from Vega or Lyra. Not from the object's outbound vector, but from deep inside the heliosphere. The resonance matched the last known signature of the ultraviolet flash perfectly, as if something nearby had received the transmission and responded softly, quietly, just enough for those paying attention to notice. Some scientists argued it was solar interference. Others suggested cosmic dust scattering high-energy particles. A few insisted it was an echo bouncing off the heliopause. But a small group, the same who had decoded the original flash, believed something far more profound. They argued that the object hadn't sent a message outwards. It had sent one inward, not to the stars, to something inside our own solar system, something that might have been dormant, forgotten, or waiting. The idea was unsettling, that the message wasn't a farewell, but an activation. As the harmonic echoes continued, something else surfaced in the data. A slight but consistent pattern began appearing in magnetosphere readings, not strong enough to trigger alarms, but too regular to ignore. The rhythm matched the same 247-second interval of the radio pulses emitted before the object went dark. It was as if the signal had been passed on, repeated, absorbed by something else. Something still here. The implications were staggering. What if the object wasn't alone? What if it was part of something larger? A system, a network, or a chain of artifacts seeded across interstellar space? Not probes sent by a civilization looking outward, but remnants of something ancient looking inward observers, not explorers, archivists of cosmic history. If that were true, then the message "We remember you" carried a meaning far greater than anyone wanted to admit. Not a warning, not a threat, a statement of recognition, as if humanity had been seen before, as if Earth had been noticed long before telescopes existed, as if the cosmos itself had a memory, and 3I-ATLAS was merely a vessel retrieving part of it. As analysts studied the lingering harmonics, one final revelation emerged. The new pulses weren't drifting randomly through the solar system, they were concentrating, slowly, almost imperceptibly, toward the region between Mars and Jupiter. The same region where countless ancient objects orbit quietly in the asteroid belt. A place where remnants from the earliest days of the solar system still drift in silence. Some believe the resonance will fade. Others think it will grow stronger. But all agree on one thing. Whatever happened when 3I-ATLAS passed the sun did not end with its disappearance. Something woke up. Something responded. Something remembered. And if the object sent its final message not to the stars, but to something already here, then the real story isn't what arrived in 2025. The real story might be what was waiting for it.